Hello and welcome back to our channel. In today's video, we're diving into the fundamental building blocks of digital electronics, logic gates. We'll explore the basic logic gates, understand how they work, and see some real-world applications. Let's get started. Logic gates are the basic elements that make up digital circuits. They perform simple logical operations based on the inputs they receive. There are 7 basic logic gates, AND or not NAND nor XOR and XNOR. Each gate has a unique function and produces a specific output. First, we have the AND gate. An AND gate outputs true or 1 only if all its inputs are true or 1. In real-world applications, AND gates are used in circuits where an action is required only when multiple conditions are met, like in security systems where multiple sensors need to be triggered simultaneously. Next, the OR gate. An OR gate outputs true or 1 if at least one of its inputs is true or 1. OR gates are used in scenarios where any one of several conditions can trigger an action, like in lighting systems where multiple switches can turn on a light. The NOT gate, also known as an inverter, outputs the opposite value of its input. If the input is true or 1, the output is false or 0, and vice versa. NOT gates are used to invert signals such as in digital circuits that require the inversion of a signal for correct operation. The NAND gate is the inverse of the AND gate. It outputs false or O only if all its inputs are true or 1. AND gates are fundamental in digital electronics because they are universal gates, meaning you can create any other gate using only NAND gates. They're used in building complex logic circuits. The NOR gate is the inverse of the OR gate. It outputs true or 1 only if all its inputs are false or 0. Like NAND gates, NOR gates are also universal gates. They're used in various digital circuits and systems. The XOR gate, or exclusive OR gate, outputs true or 1 if exactly one of its inputs is true or 1. XOR gates are used in circuits that require a true output when inputs differ, like in binary addition and error detection systems. Finally, the XNOR gate, or exclusive NOR gate, outputs true or 1 if both inputs are the same. XNOR gates are used in equality checking circuits and error correction. Now, let's talk about how these gates are realized in hardware. Logic gates are typically built using transistors. Transistors act as switches that can open or close circuits based on the input signals they receive. For example, an AND gate can be built using 2 transistors in series, where both need to be on for the output to be true. Similarly, an OR gate can be built using 2 transistors in parallel, where only one needs to be on for the output to be true. These basic configurations form the foundation of more complex circuits. By combining multiple transistors in various ways, we can create all the logic gates we discussed earlier. This transistor-level realization is what makes modern digital electronics possible, from simple logic circuits to complex microprocessors. Understanding these gates is essential for anyone interested in digital electronics and computing. Thanks for watching. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and hit the bell icon to stay updated with our latest content. See you next time.